Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue to learn about pre-processing in Scikit-learn. And in continuation to our discretization section of Scikit-learn, we'll look at column transformers and how we can use column transformer uh, to convert one hot encode pandas data frame. In previous video, we looked at how we can use k-bins discretizer, and this is kind of continuation of the same topic, and we are going to be dealing with pandas data frame this time. So let's get into Jupyter notebook and see how we can work with that. Here I've imported two libraries. We probably also need pandas, so import pandas as pd, and then we need some additional libraries. So let's import from sklearn.compose import ColumnTransformer. So that's the new library we need to import, transformer, and then we need to import count vectorizer. So from sklearn.feature underscore extraction dot text import count vectorizer, and what it does is it vectorizes a sentence into ones or zeros. So we import those. These are the versions. And for the data, I've created this data frame which you've probably seen in one of the previous videos. So we have 4 columns: city, size, title, and population. Only the population column is numeric, all others have words in them. And we are going to vectorize these columns and see if we can pass the population column as is or drop it in from going into the output column, output array. So the first step is, so let's type in here column transformer, and the first thing we are going to do is initialize a variable ct is equal to column transformer, and within this we can specify, sorry, we don't need the curly braces, we need just the square brackets. So here we can specify uh, the information. So the first column is city, so we'll rename that to be city category, and then pre-processing dot one hot encoder. Probably remember this from one of the previous videos on one hot encoding. And here we can specify the data type. So the data type is integer, and then we specify the list of columns that would follow this type of encoding. So here we can specify more than one column. I'm just going to specify the city column here. And what city category is, it's just a name given to this line of hot encoding, one hot encoding. The second will use the column size, and again we'll rename that as size underscore category, and we'll use pre-processing dot one hot encoder, and then d type is equal to data type is again integer, and the column that we are going to use for this transformation is size. And finally we'll use the third column, which is title, and for title we are going to use the count vectorizer, because we have this entire sentence. So all these, each of these words would become a separate column in the transformed array, and count vectorizer, and then we specify the name of the column, which is title. And beyond this, we close the square bracket there, and after that we need to specify what should be done with the remaining columns. So here the population column is remaining, which is not listed here. First we'll try to drop it, so remainder is equal to drop. So what that will do is in the output it will drop the column population. Now when we run this, the column transformer is not defined. So let's see why. We imported column transformer. Uh, so okay, that was spelling mistake. So once we have run this, we can look at the object that is created. Here we can see that two columns are going to be one hot encoded, and then the title column is going to be transformed by the count vectorizer. So the next step is fitting this. So we can use ct.fit and we'll fit it to the data frame that we have. And when we run this, we have the fit completed. Now we can go ahead and transform this. But before we do that, let's look at the feature names. So ct.get underscore feature underscore names. And as you can see, if we look at the data frame, so this is our data frame, the one separate column is created for each of these. So Sunmark is so each of the uh, four values for Sunmark. So four or five, it's four values for Sunmark. We have a separate column created. Each of the three values for size, there are columns created, and then each of these words from the title has a value created right here. So that's how the one hot encoding works, and that's how the count vectorizer works. And the population column is dropped from this output because we specified here that the remainder columns should be dropped. And one another point I want to note here is that the method by which we have specified these three different workflows in a list for the column transformer, that is the word that is used to describe that is pipeline in Scikit-learn. So we'll go through the pipelines in much detail in other video, but here I just want to show that this is a small example of pipeline where there is one input that is worked on by this particular pipeline, which would be the data frame. So first the column city would be worked on, then the size would be worked on, title would be worked on, then remainder would be dropped, and then the output is shown in the then the remaining, the resultant output is shown is a transformed array. So let's now go ahead and perform the transformation. Ct dot transform df, and when we run this, we get this object, and if you type to array, then we get this transformed array. Now the way this transformed array works is all these feature names that we have up above here, those form the columns. So if we look at the length of this, so if we look at the length of this list that we have, there are 19 features created. And if you look at the size of this array, so let's see if we can get the size of this dot size dot, okay, so 76 total size. You look at the shape, we have 19 columns in this as well. So each of these features correspond to a separate column. And so the way it works is we have apple. So we have 4 rows corresponding to the 4 rows in the data frame, input data frame. And in the very first row, we have Sunmark. So Sunmark is the 4th column. First is Appleland, second is Geoterrain, Skyshadow, and then Sunmark. So we have one for Sunmark there. And then moving on, there are 3 columns for large, medium, and small, which are these. And the data frame has medium in it. So medium is the middle column right here. And therefore we have 1 here and the other 2 are 0. And moving on, after that, the rest of this is coming from the count vectorizer. And let's see, we have mark which is 1 2 3 4 5, so it's 5 from the last one. So we have 1 2 3 4 and 5, and therefore we have 1 here. That's the mark word from make your mark. And the last one is yours, which is right here, and that's what we have in the last column. So that's how the one hot encoding works for the words that are there in the data frame, and that's the final array. Now if we go ahead and change something, so if we comment this out and put remainder as pass, the remainder is equal to pass through, and then run this exact same all over again, what we see now is here we have population mentioned in the feature names, because that's going to included as an additional column in the transformed array. Now here, if we go ahead and run this, we can see as compared to the output before, we now have one additional column, which is the last column on the rightmost side, which has the population information in there. So that's how we can convert one hot encode data frame into a array. Next, let's look at another feature in ColumnTransformer, which is called make column selector. What this does is it can select columns that need to be transformed based on their data type. So for that, we'll need to import another library, which is from Scikit-learn.compose import make underscore column underscore selector. So what this does is it, as you'll see, we can specify what the type of column is in the data frame, and it will automatically select that. So column transformer, and again we specify this as a pipeline in a list. Within parentheses, first one will put scale. This is just a name given for this pre-processing step in the pipeline, pre-processing, and we'll use StandardScaler. If you remember, this is going to zero mean and bring the variance to close to 1. If you want to review that, I'll put a link in the description. Then we specify make underscore column underscore selector, and we need to specify the data type that needs to be included for this. So here we'll specify np.number, and next we'll specify the one hot encoding step. So one hot, and again pre-processing dot one hot encoder, and here again make column selector. So we are not specifying any column names. All we are doing is specifying the type of column. So here now for make column selector, we can specify a regular expression to identify a column. So let's say the simplest column name identifier we can specify as city. So it will look for city, and data type underscore include is going to be object. So that's uh, that's the initialization of the variable city. And now we can go ahead and use ct.fit and then transform later, or we can do all that in one go by typing fit underscore transform df data frame. And now what we have here is the transform data frame, which has the first column, which is which it has taken the population, because that's the only column that has numbers in it. So if we want to check that, we can do that as well. So let's say s is equal to Preprocessing dot StandardScaler, and then the data frame that we have, so we need to fit on that. So s.fit underscore transform, we'll use it in one go, transform, and here we need to specify the data. So df and then population. However, if we use this, it's not going to work because it's a series and we need an array as an input. So this, if we look at this, so type, so that's a series. We need to convert this to an array. So to do that, we'll type np.array, and now this has an array, but the shape of the array needs to be changed. So we'll reshape that to -1 1. So that should be a good input, and we'll label this as SA. And now when we input SA in here, uh, so we should get an out. So this is the same output as what we had in the transformed array in the output above. So that was one way. And another point to note here is that we can look at the transformers that were used in each of those columns by calling ct.transformers formers. And if we run this, we see that the scale was the population column was transformed by StandardScaler. City column was transformed by the column that matched the expression city was transformed by one hot encoder, and then the remaining columns were dropped. In Here they were not dropped, and the remaining colors were transformed as remaining columns were dropped, right? Because the column size in this case, size and title, so size and title, they were dropped, so that's correct. Two columns were dropped. Moving on, now let's look at another variation of this, which is make column transformer. So make underscore column underscore transformer, and let's see how this works. For this, we again need to import another library from sklearn.compose import make column transformer. And again, we'll write the pipeline and put it in a variable ct make underscore column underscore transformer, and within parenthesis we need to specify right here. The first one is preprocessing dot one hot encoder, and this would be for two columns, and we can specify both of them here, city and size. And the next one is count vectorizer, so count vectorizer, and this would be again for the title column, which has a phrase for each city. And finally, what we need to do with the remainder, so that we need to specify here. So remainder is equal to preprocessing dot max abs. Let's try max abs scalar. So this would be the population column that would be transformed using this particular max abs scalar. So when we run city, this is the object we have created, and now we can do the fit transform. So ct.fit underscore transform, and we'll input the data frame df, and as you can see in the output, we get this one hot encoded columns, which are these, and then the last column, that is the converted by max abs scalar. So what it does is, if you remember, it converts the data into a range -1 to 1. So that's what happened to the population column. That was it for this video. I hope in this video you learned about column transformers, how to get input from a data frame and convert it either by a different type of scaling method for numeric columns, or one-hot encode columns that has words in it, and then put all that together in output matrix. And this is a very powerful technique because it has uh, a pipeline way of setup. And what that does is, it helps if you have a training set, this will automatically do a sequence of uh, steps, pre-processing steps on your data in that pipeline, and give you the final output array that can be used as an input to a machine learning model. In the next video, we'll look at another method which is called feature binarization. It's similar to the k-beans discretizer that we looked earlier. Until then, please like, share, and subscribe. I hope to see you all in the next video. Thank you.